Let us learn another type of data mining algorithms called association rules. In this topic, we will start talking about what is the association rules, how can we find the information out of it, and then we will dig into a deeper analysis of this algorithm, learning how can we avoid find the misleading rules, as well as how can we adapt our association rules into multi-level association rules. So what is frequent pattern analysis? In other words, what is association rules? What this trying to do is basically we try to find a frequent pattern. A pattern that can be a set of items, subsequences, because of A goes to B, or something leading to another situation, or the substructures, etc., that occurs frequently in a data set. So compare with clustering, k-means clustering algorithm. This algorithm is actually much younger. In 1993, this is first been proposed and is in the context of frequent items and association rules mining. So what is the motivation of finding association rules? The motivation is basically finding inherent regularities in the data. So for example, what products were often purchased together? This is a very typical example that you may have learned. Saying that you are a manager of a grocery store and you find information saying that customers who buy the bread will also buy the milk. Think about this. Saying that goes through the computers, we find this information. As a manager, how would you want to use this information? You have several choices. First of all, most intuitively, is that you probably want to put bread and milk together so that the customers feel very convenient and they would just come into one spot, pick the bread and the milk, and go to checkout. So customer may feel happy when you try to be thoughtful. However, use your own experiences when you goes into a grocery store, say Kroger. Do they really put milk and bread close together? In fact, they probably try to put bread and milk as far away as possible, so that when you try to pick up one thing, you need to walk all the way of the store, and throughout the walking, you're probably going to buy something that are not really necessary. And then when you finally find the milk, it's actually walk probably the whole Kroger's already. That is some strategies you can think about. Of course, there's also some possibilities that you want to put bread and milk together for a sale, or you don't want ever put bread and milk on sale together at all because customer would just want to buy them naturally. So you can see that there's a lot of strategies you will be able to use if you find this kind of information. And of course, for computer scientists, our job is try to find those rules so that the decision makers can use that knowledge and make some strategies on it. Other examples are what kind of subsequent purchases after buying a PC. So after you buy a computer, maybe softwares, maybe keyboards, maybe a specific mouse will go along with the PC that you purchased. In terms of bioinformatics, what kind of DNA are sensitive to these new drugs? Can we automatically classify web documents? And all of these are able to find what we call the frequent patterns, and the application of using this can possibly be a basket data analysis, which is typical bread and milk analysis, cross-marketing, catalog design, sale campaign analysis, web log analysis, as well as the DNA sequence analysis. In this world, web log is something actually heavily studied because people want to see, after you look into this web page, does that link you to the shopping cart, and does that links you to pay the products? There's a terminology over here is called conversion rate. So basically, what is the conversion rate from this product page to money? And all of these are parts of the interesting association rule analysis. So to study this, we can use the most basic version of the association rules, which is basket analysis. Saying that we have a customer go into a grocery, purchase milk, bread, and cereal. So that's the first customer's basket. And we will be able to look into the second customer, third customer, as well as several customers. And then we try to find, are they purchasing something together frequently, or they don't purchase those things together at all. So there's a lot of different things can happen over here. Therefore, for the idea of the association rules, there are two important computations that are required to identify what we call a strong association rules. Those two important things are support and confidence. So what is a support? Support is the probability that a transaction contains X and Y together. You can see the equation is super easy. When you try to buy X and Y, saying those are two things, X can be milk, Y can be bread. So among all of your transactions, you can see that it's divided by absolute value of T, indicating how many transactions that you have. Saying that you have 10 transactions, you want to see how many of those transactions a customer buy milk and bread together. So saying that in your 10 transactions, 5 of them buy milk and bread, and therefore that you can see for the support of milk and bread can be 5 divided by total number of transactions, which is 10. So the support in this particular example is 0.5 or 50%. Compare with support, the other one is confidence. Confidence is something very similar to support. The only difference is that the precedent need to be considered other than like support, precedent, and the consequent are just putting those things together without any special consideration. The reason I'm saying that is take a look of the confidence. Confidence, conditional probability that transaction having X also contains Y. So you can see that for the equation of the confidence, indicating that when X and Y union together, how many times of X and Y milk and bread are purchased together, divided by the precedent of the purchasing times. So you can see that instead of absolute value of T, here is the absolute value of X, indicating the precedent of the confidence association rules that we want to find. So in other words, saying that we have milk and bread being purchased 5 times as our previous example, and in these transactions, basically milk has been purchased 6 times. And 5 out of 6 times that they are being purchased together. And that is the confidence, which is also considered as conditional probability. These two things is are a little bit complicated. So basically, I want to separate these two things into 2 parts. So first of all, we want to focus on the support. After you understand the idea of the support and confidence, we will need to set up a user-defined value, which what we call a minimum support as well as the minimum confidence. In other words, minimum support indicating what is the minimum value of the support that you want to consider that is part of the frequent item set. And the same thing will need to be done on the confidence. As I mentioned, let's focus on support first. And we will have another video focusing on the confidence. So support, which is the probability that a transaction contains X and Y altogether, X union Y divided by the total number of transactions. So saying that this is our transaction, we open up a very teeny tiny grocery stores, so that throughout the day, there's 9 transactions. And we want to list out all of these 9 transactions according to what items they have been purchased. Obviously, this grocery store does not have a lot of products. We only have like 5 products. So the first customer buying product 1, product 2, and product 5. So you can think about milk, bread, and cheese maybe. Customer 2 will buy item 2 and 4, etc. So the total number of transactions in this example are 9. Saying that we set up a minimum support equals to 2 divided by 9, indicating that at least the frequent item that we want to identify need to occur more than twice, so that we will understand this is actually meets the minimum support here. In this case, since the support is defined by X union Y divided by total number of transactions, I want to emphasize one more time, the total number of transactions in this example equals to 9. So because we have 9 transactions over here. So let's take a look at this. Since the grocery store has only 5 items, the basic way of finding the frequent items is that we try all combinations. We have 5 items, and we want to find what are the 2 items that are being purchased together all the time. And therefore, what we need to do is that we need to find all possible combinations. Item 1, 2, item 1, 3, item 1, 4, item 1, 5. And of course, we can also see item 2, 3, 2, 4, and 2, 5. And now starting from 3 to 4, 3 and 5, basically we will be able to list out 4 and 5. All of these things we want to see that how many times they have been purchased together. Every time we list out one item, we need to see how many times that they have been purchased together to see if that frequent item pass the minimum support or not. In this case, item 1 and 2, take a look of the transactions that I listed over here. 1 and 2 has been occurs once, twice, 3 and 4. 4 out of 9 times. Since our minimum support is going to be 2 out of 9, we see that it actually passes. If we look into another example, 1, 5. So we have 1, 1, 5, another 1, 5. 2 out of 9 times. That also pass the minimum support as long as we assume minimum support equals to 2 out of 9. We will be able to calculate the support 2 and 3 as well. So you see that 2 and 3 has occurred 1, 2, 3, and 4 times as well. So that also pass. If we want to see the support 3 and 5, which is listed over here, we will find out that 3 and 5 is actually occurs only once. So this is not something that we will consider it passes the minimum support. So you can see that we can list out all permutations of the items that we have over here and then check one by one to see if they pass the minimum support. This is only a small part of it because we only consider in this page 2 item set, which means that we want to see our 2 items being purchased together frequent enough or not. It is also possible that we expand that concept into 3 item set. Because you can see that in this case, there are some items, 3 items are being purchased quite frequently together. So we would also need to try all combinations of 3 item sets if we don't do anything special. In this case, we need to list out all possible 3 item sets starting from item 1, 2, 3, 1, 2, 4, 1, 2, 5, 1, 3, 4, 1, 3, 5, and 1, 4, 5. So all of these 3 item sets starting with item 1. We will need to do that for item 2, 3, etc. And of course, every time we do that 3 item set, we need to look into the data set, scan the database to see how many times that have been occurred together. So 1, 2, 3 has occurred 2 times over here, so it passes the minimum support check. If we want to look into the support 2, 3, and 4, you will realize that it actually never happened in our data set. So of course, that's not going to be able to consider as part of the association rules. Same thing with 3, 4, and 5. If we can expand from 2-item set to 3-item set, we can also expand that to 4-item set. So this time for the 4-item set that we listed over here, 1, 2, 3, 4, 1, 2, 3, 5, etc. Then and 2, 3, 4, 5. So that we have like 3 different 4-item sets. In this case, we will also need to check if there's any items occur in 4-item set information, and we'll realize that actually none of these items has passed the 4-item set check, because think about this, there's actually only one transaction that's purchased 4 items, and therefore since our minimum support is 2 out of 9, there is no 4-item set for us to check necessary. Finally, 5-item set, because we have 5 items, is also something that we need to put into consideration. And as a matter of fact, like I mentioned in the previous slide, we will not see any 5-item sets over here. And that's what's going on for us to go through a thorough check, finding out all kinds of possibilities over here, and then to see if there's any potential rules that pass the minimum support. The problem is this: we doing this, and there's a lot of calculations already. And think about this: this is under the situation that our store has only 5 items. In reality, the grocery store may have thousands of items, and in this case, if we want to do similar things, try to scale the idea of the minimum support calculation, it will require a lot of calculation time. In fact, this is probably not something doable when we have thousands of items in terms of our bigger analysis. And that is why we want to discuss, we want to see if there is a better way of doing so. So in our next video, I want to talk about what we call the association rules with a priori.